All right, hello everyone. The time is 2:52, and today we are going to be starting at 3 o'clock as usual, and we're going to be talking about rocks today. So if you happen to have your books with you, that'd be great, just because then you guys can reference some of the diagrams in the book. Also, if you have your rock kit on hand, that's great. If not, go ahead and run and grab your rock kit. We won't be looking at too many of the samples from the rock kit today because their igneous collection is kind of lacking. It's not really up to my standards. But I wanted to save you guys $25, so we went with the smaller kit. But that's okay because they've got some really good igneous and metamorphic rocks. But we'll just be looking at a few of the igneous ones for today. So let's check in. How's everybody doing? How y'all doing? I've been doing decent myself. Behind on grading. Sorry, guys. I'm working on getting caught up there. I actually work 2 jobs on campus. I'm also a lab technician for the physics department and the geology department. And I had some work requests come up Friday and over the weekend and stuff that kind of took up some of my time related to my lab tech position, as well as just the general trying to convert stuff from this class to an online format, as well as drastically improving the class from the last time I taught it a couple years ago. So as a result, I am behind in grading, but I'm going to do my best to get caught up and not fall behind. Let's see. Oh, we had 3 watchers. Now it looks like we're down to 1. Maybe there's some buffering issues going on for some of you guys. Yeah, so we'll start in 5 minutes. Noah's good. Noah's good. Hopefully you had a nice weekend. Looks like we got 1 viewer back. And let's see. Someone says that they, Michaela apologizes in advance for attempt at drawing rocks. No worries. I'm not expecting anything fancy. Just kind of a basic sketch that tries to capture the shape of the samples and just kind of some of those key features. This may not be the last time in the quarter that I request you guys sketch something. There will be one other lab where you guys will have to sketch some things. But again, not really expecting anything fancy. Quite frankly, the idea behind sketching something is that you actually get you get a better sense for what the sample looks like when you sketch it, right? Sketching a sample makes you really pay attention to what it is that you're looking at. and really brings your attention, and you just see all the details and such. So it looks like we got a few more viewers. How y'all doing today? Just check in. How are people doing? Starting at 3. Pretty good. Yeah, I've been having trouble sleeping during this quarantine period, actually, oddly enough. Yeah, a few of you guys are sleepy. Yeah, just odd things with like trying to sleep, either weird dreams, or I've just been waking up at odd times and being like, well, I'm awake now for the next hour or two, before I can get back to bed. Anyone else like just having weird sleeping during quarantine? There's usually a delay too for that chat. Yeah, wake up for an hour between 3 and 4. That's my favorite time to sleep, is between 3 and 4. I live next to a freeway, and the freeway is quietest between 3 and 4. And I can usually tell what time of night it is by how loud the freeway is. Yeah. Yeah, pets waking you up. That's why my husband doesn't want to get a pet. Probably should exercise more. Yeah, me too. I've had some cold-like symptoms though, so I haven't been exercising the last week or two. But prior to that, I was doing decent. I'll need to get back into it. So, got about 1 minute to start. Or till start, 1 minute till we start. Checking out all my rock samples here. I went to campus and raided our geology rock collection because I have some of these samples myself that I want to show you guys and talk about. But I don't have all of them. And also the college just has way better ones. I mean, how can you not when you've been, donated samples for years by people who either like a loved one who used to collect rocks will pass away and they'll donate like a large collection to the college. Yeah, that's typically a big one when stuff gets donated, is if like a rock hound passes away who collected their whole life, and then they donate this amazing collection to the college. But yeah, so anyways, let's start talking about rocks. How many of you, out of curiosity, took this class? I know most of you guys took it because it probably sounded easier than the other science classes. It's okay. I understand. That's how I got into geology too. I had a choice in my senior year at my school between chemistry and geology, and chemistry sounded scarier to me than geology did. But how many of you guys took this class also, or maybe because you find rocks a little bit interesting? Maybe you were someone who collected rocks quite a bit, or like as a kid, would pick stones up, maybe on the beach. I know I did from time to time. I wasn't really super into it though, until like my senior year. But how many of you guys, show of hands, sounding off in the chat, how many of you guys are maybe mildly interested, like, I think that's kind of cool. Okay, we've got at least one. So that's awesome. Okay. Economics and casting and rocks are definitely in that field. Earth science major, right. Yeah. So then this chapter will be hopefully especially interesting to you guys, and maybe at the end of this lecture you'll even be able to look at, if you guys like maintained a rock collection or something, or kept some of the stones that you collected over the years, just picked up, maybe you'll even be able to look at some of those and be like, oh, I know what this is now. So for the lab for this week, you'll notice that for part of it, you're going to be looking for rocks around your home to identify. And you're going to pick 3 rocks that are not the same rocks and that are not from your rock kit. And they can be a personal rock that you've had that you picked up at some point, or maybe you have rock countertops in your home, like in your kitchen or like a bathroom or something. Or perhaps you'll go outside and like walk around your house. Maybe you've got a ditch outside your house, or maybe a walk through your neighborhood using proper social distancing protocol and safety and whatnot. Find 3 rocks, 3 different rocks, and you're going to photograph them and turn in those pictures. And you're going to identify as being one of the 3 types of rocks: igneous, metamorphic, or sedimentary. We'll go over more on how to tell whether a rock belongs, which class a rock belongs in. Let's see, let's go ahead then. And then the rest of the lab, I almost forgot to mention, the rest of the lab is going to be filling out, similar to last week, filling out a lot of those charts that have ask about certain characteristics for certain types of rocks. It's a little bit different for each of the 3 rock types because there are different features that are worth paying attention to for the different rocks. Excuse me. And you'll be using mostly your book for finding out this information, but you're also welcome to use the internet as well and other websites that look fairly credible and like they weren't put together by a high schooler, you know, or whatnot. Something that looks like some professionals wrote down the information, where they look like they actually have some credit to their name to be talking about the things that they are talking about. So let's dive into today's lecture. The PowerPoint, I put a link to the Google Slides. The reason I did that this week instead of like a PowerPoint that you can, like a PowerPoint format, and just give you guys the link, is because I do plan to update that our PowerPoint either between tomorrow and our lecture on Wednesday. I only really had time to refine the first half of our lecture, what we're going over today. So more to come on that. Noah asks, how are we supposed to do the lab assignment? I would need a more specific question. And there are instructions on the lab assignment as well. So let's go ahead and go over those specific questions kind of at the end of lecture. But yeah, I definitely, if there's anything in the instructions that you're confused about, let me know. But let's go ahead and start the lecture slides. So for the first slide there is kind of just an outline of what we're going to be covering. We're going to talk about the rock cycle. We're going to talk about, in this whole week, we're going to talk about magma and igneous rocks, and we will talk about that today. We're also going to talk about weathering and sedimentary rocks. We'll talk about weathering today, but we won't get into sedimentary rocks today. And then on Wednesday, we're also going to be talking about metamorphism and metamorphic rocks. And I put a wonderful meme here for all y'all to see. on this PowerPoint. Found that one online and just about died laughing. I know my rock collection is quite extensive. But hey, a lot of it I found myself. I did a lot of the collecting while I was a student. So a good portion of my collection has actually, not purchased. So let's go ahead and dive into talking about the rock cycle. Which one usually wins? I'm not sure what you mean, Alicia. Let me know. Oh, I know what you mean. You mean in this one, in the meme. Which one usually wins for me? I do tend to buy food to survive most of the time. I'm not too terrible with rocks. But this conversation does come up when I visit a rock show. And I see so many pretty things there that I'm like, oh, I don't have anything like that, or that's really gorgeous. Usually what I've started doing is that I just withdraw a certain amount of cash before I go to like a rock show. And when that cash is gone, that cash is gone. So that's how I roll these days. But let's go ahead and talk about the rock cycle. Before we start talking really in depth about the rock cycle, I need to first flesh out a little bit more that there are 3 types of rocks. We also talked about last week how minerals are the building blocks of rocks. So all rocks are made up, they're all an aggregate of these minerals that we learned about. We learned about a few. There are many, though. I have a book about this thick. Actually, it's probably on my table somewhere. There it is. Just in case you're wanting to know how many minerals there are, this book of mine, Rocks and Minerals, Peterson Field Guides, highly recommend. I like it. It's this thick and it's dedicated to minerals. So I only had you guys talk about a few minerals. But these minerals, when they are all consolidated together and form one, mass, then it is called a rock. So this rock is made up of an aggregate of minerals, right? And I have a great rock here. This is actually a pegmatite, but we'll look at this probably again today. But you can see here some of these pink feldspar crystals, some of these black biotite and hornblende crystals, right? And each one of these kind of colored dots in here, odd-shaped blobs, is a mineral, a different mineral. And you can see that this rock is composed of a bunch of minerals stuck together. So what kind of, what basically constitutes how you define the 3 different types of rocks then? Well, it has to do with how the rock was formed. So igneous rocks, which you'll see abbreviated probably on my, you may see abbreviated in any text that's on my slides, IG, or for taking notes, that's how I like to abbreviate it, is IG. Igneous rocks form directly from molten material, liquefied rock material. So, and when that liquid, which is magma or lava, we'll talk about the difference in a moment, when that magma or lava solidifies, those minerals solidify out of it, right? And you eventually end up with something like this. And igneous rocks that form from molten lava magma have various texture characteristics to them that make it really easy for someone like me, and hopefully for you guys kind of by the end of this chapter, to tell the difference between igneous rocks, right, and metamorphic and sedimentary. They have different looks to them and different kind of textures overall. So an igneous rock is one that formed directly from molten material. Sedimentary rocks, on the other hand, are different. They form from the compaction of various rocks, material that's already solid, right? And it could be any kind of rock. So material that's already solid, we don't have liquid magma or nothing, and it's compressed together, and usually like a little bit of natural cement, which is kind of like this mineralized water, precipitates in there, and it glues the particles, the solid rock particles together. I have, where did that one sample go? I like this one a lot. I'll show you guys this one I got in Idaho. So you can see that there's just different like chunks of rock in here. There's also a fossil right there, a fossil coral there. I've got another one down here as well. This one is from the college. This one's pretty awesome. You can see all these different clasts, these different smaller rocks and, you know, mud and other things that were compacted together and cemented together and formed a solid piece of stone. So there are other ways, there are kind of some other details in sedimentary rocks that we will talk about more. There are other ways that they can get cemented together, but that's kind of the basics, right? So metamorphic rocks are yet another entirely different story. It's where you take an existing rock, and rather than cementing together different bits and pieces of rock or forming from a, you know, molten material, you take a piece of rock and you expose it to really high temperature and pressure. And under that really high temperature and pressure, rocks will actually recrystallize. They will kind of become, again, like that. Think about the candle wax that is really hot, but not quite liquid. And it's malleable enough to move around, right? And it will, these rocks that are under this tremendous amount of pressure and heat will indeed actually recrystallize. So nervous when you hold large rocks up over your laptop. No, my laptop is actually kind of propped back a little bit, so I don't really hold them over. Well, I do, I guess, when I show them up close. No, I'm good at this. Watch that be the death of me. And one of these rocks falls on my keyboard. IT, I'm doing my best, I promise. I'm sorry. So let's go ahead then and move on to the next slide. And if you'll notice this first slide here, right, we've got a diagram here showing an igneous rock, a sketch of, you know, a sedimentary and a metamorphic rock. There's a reason why. It's because on the next slide, I've filled in kind of some of the gaps there. And the rock cycle basically talks about how these three different types of rocks are related to each other, because they are indeed related to each other. So here on this diagram, let me try and get this a little bit better there. We can see that we have molten rock here, and then it becomes an igneous rock. Here we have sediments, right? Just these loose, unconsolidated, already formed rocks. And when they are compacted and cemented together, they form a sedimentary rock, right? And then metamorphic rock. I didn't really have a good picture to show like temperature and pressure exposed to, you know, pressure and really high heat. But yeah, and then metamorphic rocks. So Some of you guys may have heard this, but probably not. Rocks, basically, any type of rock can be transformed into another type of rock. I like to think of rocks as like the kings and queens of the reduce, reuse, recycle mantra, because you can take any type of rock, right? You can take any type of rock and you can transform it into one of the other types of rock. What do I mean when I say that? I mean that you can melt down a sedimentary rock, or you can melt down a metamorphic rock back into completely liquid. And when that recrystallizes, it'll be an igneous rock. Yeah. Or you can take either an igneous rock, something that formed, one of the types of rocks that formed from molten material, or you can take a sedimentary rock, either or, and you can expose it to really high temperature and really high pressures and transform that into a metamorphic rock, and it can undergo that process. Sedimentary rocks, likewise, you can take either an igneous rock, or you can take a metamorphic rock that's, that they've solidified and turned to stone, and you can break those down into smaller bits and pieces and then create a sedimentary rock out of those. So that's why this diagram has all these arrows all over it, showing that, hey, this kind of rock can go over here and become this kind of rock and stuff. You also have a diagram of this in your book. Theirs looks a little more complicated than mine, because it has more information on it than mine does. I like to start out with this diagram, though, where you can see the arrows going from each of the different rocks and how they form, right? This is the diagram that's in your book. See there on page, what does that say? 47. All right. So you can turn in your books to page 47 if you want a closer look at that. But yeah, the rocks are kind of the champions of reduce, reuse, recycle, because that material rocks just keep getting over time recycled into a different type of rock. Let's see. Sedimentary rocks are the types that you find fossils in. Yes. And we might talk a bit more about fossils. Let's go ahead, though, and transition into igneous rocks, and we will start up on that. So just some really pretty picture to show you guys of some lava just bursting out of a volcano there. Yeah, I did include that slide just to have that pretty picture on it. But also, this diagram is worth noting. I don't believe I put it on your next slide here, showing a volcano. This portion right here, that somewhat orangish red spot, is lava that's pouring out. We also have magma down here underneath the volcano. Magma exists in more places than just right underneath a volcano. Little pockets of magma in the crust where you have actually molten material. But most people are familiar with it being directly under a volcano. So talking about igneous rocks, it's really important that we first start with talking about what the heck is the difference between lava and magma. I didn't really think about that until I started learning about geology, because they're both liquid rock, right? Are they the same thing? No. The difference is that lava is molten rock that is above the Earth's surface, and magma is liquid rock that is still inside the Earth. It's still below the Earth's surface. Same thing, but the terms denote location, right? Lava is already erupted onto the Earth's surface, and magma is still underground. So, again, igneous rocks are rocks that form, kind of going on to the next slide here. Igneous rocks are rocks that form from a liquid state. So you've got liquid rock recipe stuff, right? And a igneous rock is the rock that you get from that material, right? And this igneous rocks can solidify above ground, or they can also solidify underground too. Magma that's underground can cool and start to solidify and harden. And whether the molten material solidifies above ground or below ground, it produces some drastically different textures in the rock that help us, are going to help you guys actually identify your rocks in your kits and such. So let's go ahead then and just keep plowing through these slides. So a rock that forms on the Earth's surface from lava, we have a specific name for that kind of rock. We call that an extrusive igneous rock. And rock that forms below the Earth's surface, we call that an intrusive igneous rock. Think extrovert or introvert, right? Extroverts, they're very, a lot of them is, they really are very gregarious, right? They talk a lot with other people, right? A lot of their emotions are out and you can see them, right? Introverts are really like keep to themselves. They keep everything kind of inside themselves. So extrovert versus introvert, think intrusive versus extrusive. So extrusive are the rocks that form above the Earth's surface, and intrusive are those rocks, intrusive igneous rocks are those that solidify below the Earth's surface. So let's take a look at some intrusive and extrusive igneous rocks. So the rocks on this side here are extrusive igneous rocks, and the rocks here on this side, these two, are intrusive igneous rocks. Go ahead, and I want everyone who's watching, there's 9 of you, so I want to see 9 comments in the chat area saying some observations that you guys notice about the difference between this side, the extrusive igneous rocks versus the intrusive igneous rocks. So what do you guys observe about these? Some maybe some similarities, differences, etc. I'll keep holding that up. You turn on another light here too, see if that helps at all. Not really. But hey, we're trying. So let's see. Someone has a rock that formed from Hawaii 10 years ago. That's awesome. Very young rock. Smoother extrusive, bigger grains in the intrusive rocks from Alicia, Genesis. The extrusive rock looks smoother. Echo says the amount of spotting, more solid and less, right? Yeah, this one has more spotting, right? These ones look kind of smoother, right? And then the grains look bigger over here, right? Versus, if you can even see any grains over here. Let's see, still waiting on some more comments to come in, right? There's 9 of you. We should have more comments. Some more observations. And these observations are great, by the way, what we've got so far. They're basic observations, and that's really what we're looking for. I'm not looking for anything like super fancy, just the basic observations that you guys are making. One looks smoother, one has more dots than the other one does, you know, bigger grains than the other rock. Those are excellent observations. Any similarities? I think some of you guys may have walked away from your computer or something like that, because we're not getting any more comments. But any similarities that you guys noticed between the sides? Noah says that the rocks on the right have patterns. Shape. They do have all kind of a squarish or rectangular shape. Yeah, and these two kind of have a similar shape. That was unintended. No easy cleavage. We don't tend to see cleavage really on rock samples. That's something I should have noted. So before we go further, I need to clarify this, because forget, a lot of 101 students don't realize that cleavage is actually something that is specific to minerals. Not that that's not important for rocks. So when I identify rocks, and when you guys identify rocks, you're going to be looking at, if you are able to, the individual minerals that are inside your rock, right? And you're going to find a grain of, you know, something, try to figure out which mineral that single grain is. And you are going to look for cleavage planes on that particular grain to determine, is it a quartz grain? Is it a feldspar, you know, like a plagioclase, or a potassium feldspar? Is it a grain of biotite or muscovite, etc.? However, the rock as a whole, because it is made up of an aggregate of a bunch of minerals, it itself doesn't really have, we don't characterize it in terms of cleavage, right? Cleavage is determined by the chemistry of those minerals, the bond angles, and how those bond angles break and stuff when you cleave the rock, cleave the mineral. And we don't really have that happening so much with a rock, because it's made up of all those different ones. I didn't realize that that was something that was kind of a tripping up point until I first taught geology. And then I was like, oh, I really need to define this for people. So two of them seem like a combination of different things, and the other two seem like one concentration, similar colors. Yeah, so I think what you guys are both noting there is the fact that these ones are lighter in color. The top ones are lighter in color, and the bottom ones are both darker in color. That's going to be important. That's exactly what I wanted you guys to pick up on. So let's go ahead and move on to that next slide then, and further kind of digest igneous rocks. Let's first talk about these fine-grained rocks. What you guys were looking at here on this slide, we call these, this is fine-grained and coarse-grained. And this is honestly the last time that I'm going to have you use those terms in regards to igneous rocks. After this slide, we're going to move on to more advanced terms to replace the terms fine-grained and coarse-grained. But let's stick with those for a moment, just briefly. So fine-grained rocks, these fine-grained ones that we're looking at here on this side of the previous slide, as well as on the top of the next slide, right here, these three on the top, those ones form above ground. And they are made up of mineral crystals and individual mineral grains stuck together. However, they're just so tiny that you can't see them with the naked eye. Sometimes they're so tiny that you can't even identify the mineral sometimes, just with the naked eye, and you need to have a thin section and put it under a microscope. Usually you can tell by the way the light reflects off of these rocks, or at least I can, that it is still crystalline and it's still igneous despite being so fine-grained. It kind of shines a certain way. And you may still be able to tell that there are individual crystal mineral grains in it, but it's just so fine-grained. So I have some examples here. Let me pull out this sample as well as... let's just stick with this one sample here. Do you guys happen to have a rock that looks like this in your kits? I'm going to put a background to it, so hopefully it maybe focuses a bit better on it. I think my camera is just not going to be good enough. You can see a few tiny, shiny crystal grains in there, but overall, it's just like ground mass, right? This rock is, as we would call, fine-grained. Do your rock kits have something that look like this? I'm wondering if your samples, which were the samples that I'm wondering kind of look like this? I'm wondering if your porphyry looks like this. Hopefully, which is your sample number 10. Hopefully your number 11 doesn't look like this. Hopefully your number 11, even though it says granite fine-grained, I hate that term. I'm so sorry, guys. Even though it says granite fine-grained, what they just mean is that it is, it's not fine-grained. It's just, yeah, that's why we have to move on from these terms, fine-grained and coarse-grained. Right now, when I say fine-grained, at the moment, I mean something that has crystals that are so small that you can't see them. In your kit, when they say fine-grained, they just mean you can still see them, but they're really small. I think so, maybe number 24. Number 24 should be in a different, yeah, that would be a different one. So that's not the same thing as this little guy here. Okay, so, but moving on then, regardless, this is a great example of a rock that is fine-grained, as in you can't see the individual mineral grains, save maybe like one or two little strays in there. So these fine-grained rocks, we're going to start calling them, moving forward, we're going to give them a different name, guys. We're going to give them a different name. But these rocks form above ground. And they have only small crystals that are invisible to the naked eye. Why is that? Why are the crystals so small? Any guesses for why the crystals are so small? Let's see. Longer cooling periods. Let's hear some more guesses too. I want to hear from more than just one person about your ideas for why you think the crystals are so small. Keep them coming. I'm gonna put something up on the background. Something to do with the rate of cooling. It does have something to do with the rate of cooling. So the reason why the crystals are so small actually is the opposite. It's because it cools so quickly that while a melt, a liquid rock, while it's cooling, the crystals are growing as it's cooling off and solidifying. And the longer that a that a magma or a lava has time to cool, the bigger the crystals can grow. They can continue to grow in that nice, warm, liquidy melt. Yes, not all the crystals crystallize at the exact same time. You kind of get some forming a little bit sooner out of the melt than others. More details on that to come. But basically, these crystals in these extrusive igneous rocks, they form out on the Earth's surface, and it's pretty cold out here compared to underground. And so there's just not a lot of time for these big crystals to grow. So we get these really small crystals that are just too small to see. Sometimes when igneous rocks erupt onto Earth's surface, it is so cold that the rock cools, that the melt cools instantly and forms a rock that has absolutely no crystalline structure, and it forms a glass that we call obsidian. I happen to have a small piece of obsidian here that we'll look at really quickly. Nice piece. It has a little bit of mahogany on it. So nice little piece of obsidian there. And again, these extrusive igneous rocks that form above the Earth's surface, there may have been a few crystals that crystallized out of that molten material while it was still underground, as you know, magma. Few crystals might have formed underground, and then when it was extruded out of the volcano or out of a fissure, what have you, those individual crystals that formed underground and had a little bit of time to cool down and grow kind of a little bit bigger will be extruded with the rest of the stuff. And then everything around it cools pretty quickly, and you get that fine-grained ground mass. So let's talk about the other type of rock that have bigger grains, right? These are the intrusive igneous rocks. These ones form underground. They have more time to cool off, and those crystals are able to grow really, really large. And so we can see those crystals. Right? So something else that I want to draw your attention to, we will talk a lot more about this in a few slides, but there is a reason why I have these, actually this diagram I think is in your book, or maybe it came offline, but there is a reason why these are lined up like this. And you see kind of pinkish colors here, and you see kind of some more salt and pepper, kind of like in the middle colors here, you know, both light and dark, maybe medium gray. And then over here, you see really dark colors, mostly dark colors. That's really important. Spoiler alert, same chemical composition above ground, below ground. Same chemical composition above ground, below ground, etc. More on that to come. In the meantime, let's talk about textures. Let's replace those god-awful terms of fine-grained and coarse-grained, because we need to use those terms somewhere else. We need to use those terms, quite frankly, when we're talking about intrusive igneous rocks, and we need a term fine-grained and coarse-grained for when we talk about how large in comparison the crystals are to one another. Let me find a good I guess this one will do. Let's go with this one. Coarse-grained, less coarse-grained, more fine-grained, right? These crystals, I wish I could hand you this sample because I love this sample. It's ridiculous. It's actually a pegmatite. I think I said that already. But these crystals are they're gigantic. Like compared to the size of my fingernail, they're huge, right? And then compare these crystals to the size of my fingernail. Not nearly as big, right? Look at the black dots and stuff. Finer grained, coarser grained. We need those terms really to talk about those intrusive igneous rocks. So, well, then what the heck am I supposed to use when I talk about the difference between extrusive versus intrusive? And you guys are like, but I need a term. I need a term for this texture versus this texture. You took away my fine grained versus coarse grained. It's okay. The term that we're going to use to describe these rocks, the extrusive igneous rocks, is aphanitic. So, looking at this slide, everybody always wants cookies when I do this lecture. I'm sorry. You'll all be baking cookies after this lecture. I promise you. So, right here, make a little note that says aphanitic. Spelled A. I'll actually just type it in the chat for you guys. Yeah, I see a question already. So it's actually spelled with 2 A's, aphanitic. Very close spelling. I mean, how the heck are you supposed to spell aphanitic? So this is aphanitic here, right? When do you want to use the term aphanitic? There is a very specific time. You really want to use it when your extrusive igneous rock, oh no, where did I put that other sample? There it is. There's some holes in this rock, and there's a couple crystals, but we'll ignore those for now. So think sugar cookie for the term aphanitic. You shouldn't be able to see like any visible crystals in this extrusive igneous rock. And I have here depicted below, in case you're curious, we'll talk more about it, is this picture of a rock called rhyolite. And there are no visible crystals in it. Think sugar cookie. When you see it, you're just like, oh, look, it's all kind of uniform in texture. You know, there's no like big globs of anything kind of standing out. It's just all the same uniform sugar cookie matrix, right? Moving on to the next term, because we have one more texture. I classify this texture as being an extrusive igneous texture. Some people ask me if it means it's both. I don't like to call it both. I like to call it and designate it as being an extrusive igneous rock texture. The next texture that we're going to talk about is when you have both fine-grained aphanitic ground mass, right? You've got the sugar cookie ground mass going on, but you also have some visible crystals in here too. See those black dots? If I were to hand you this rock, you would see those crystals like shining and reflecting back, and you would know, yes, they are indeed dust. I don't know if you guys could see that. That was hilarious. See, we've got this gray ground mass going on here. No crystals visible in that to your naked eye. But you can see these black dots here. And, oh, there we go. I've got some of them glinting in the light. Those are lovely hornblende crystals. Tiny, but still visible and identifiable with a hand lens, a magnifying glass, right? Those dark grains where you can actually see crystals, we kind of in geology like to have those as an analogy of like chocolate chips in a sugar cookie, where all the gray stuff is like that sugar cookie ground mass, and then the individual crystals in there are like chocolate chips that you can actually see, oh, hey, look, here's a big giant single grain. And I'm capable of seeing it. I've got another rock here that's of a different color, but has this same texture. The texture is called porphyritic. Your book actually calls out this texture, porphyritic, where you have these large crystals right? Some of the crystals in this one are kind of more of a white color, right? And some of them are kind of a gray color. There's one right here. And then we've got this kind of grayish pink ground mass going on behind it that is just, there are crystals, too fine to see, too tiny to see with the naked eye. You can see them under a microscope though. So those white and black and gray dots in here are the chocolate chips in our sugar cookie. And we call that porphyritic, meaning two textures. You got the big chunks and the small chunks. So think chocolate chip cookie for porphyritic, right? Let's move on to the last type of texture. Your book calls this coarse grained, and that's a god-awful thing to call it. We are going to talk about, this is intrusive igneous rock texture. They call it coarse grained. No. We're going to use the term phaneritic for this. And yes, chocolate chips. So here we have just a bowl of chocolate chips. Why? Because chocolate chips are really big and you can see them with your naked eye. Sugar cookies, like the individual stuff that makes up the matrix of the sugar cookie, you can't really see that with your naked eye if you made the cookies properly. If you didn't mix your cookie dough well enough, you'll be able to see the sugar crystal grains. That's bad though. You have to cream your dough. You shouldn't be able to see individual sugar crystal grains. That's how you know the ones at the store are crappy, because they don't actually cream their dough and get those sugar crystals to dissolve in it. So here we have the bowl of chocolate chips. It's just large things that you can see. There's no fine-grained ground mass where you're like, I can't see the crystals. It's just like a wash of color. It's like, nope, everything is just one big giant crystal and you can see the cleavage and you can see everything on it, right? So I will hold up these 3 examples that I have. I'll try to hold all 3 up at the same time over my keyboard. Dear IT, I hope you never see this. Because I rented this laptop from them. This one here, we have our aphanetic texture. Over here, we have our porphyritic. And here we have our phaneritic, right? Really large crystal grains. You can see them. You can see every single one of them. There's no ground mass. Here, we have some grains that you can see and make out what they are, which mineral they are made out of. Hornblende or quartz or feldspar there, potassium feldspar. But we have some ground mass, and this one is pretty much just all ground mass. Right? So now I'm hungry. Yeah, I know. I think the next time I do this class in person, wish I could have done this in person with you guys. I always want to bring cookies with me when I do this lecture because I also want cookies after I do this lecture. All right, so those are the terms. And one last quick recap before I move on to the next slide. Stay with me here. We have our rock that formed the entire rock. All the melt solidified above ground. With this one here, there was a little bit of crystals that started forming underground. And you can see those. They're the dark ones in this particular rock, or in this one I had some light ones too. And then the rest of the rock formed above ground and formed that fine-grained ground mass. And this one completely formed underground, because you can see all the nice, big, large crystals. Chocolate chip oatmeal cookie. I love chocolate chip oatmeal. Leave the raisins out, though. Those don't belong in cookies. All right, so what can igneous textures tell us is the next slide here. This diagram is also in your book on page 50. We're going to mostly save this diagram for when we talk about volcanoes. And I'm going to talk a lot about the different type of extrusive igneous textures, because not only do you get fine-grained ground mass like this, that aphanitic texture, you also get a lot of really other interesting features that, in addition to this, occur in the rocks. And we're going to talk about that with the volcano chapter. And we're going to talk about how that all comes to be, and it has to do with the volcanic. It has to do with other stuff that we're going to talk about then at that time. But you can see that you get a wide variety of igneous textures. Right here we've got the obsidian. We have a thing here called pumice and ignimbrite. Actually, they call it pyroclastic fragmental, right? And then we've got like the aphanitic, the phaneritic, and the porphyritic there. It's really easy to get those terms mixed up. It is so easy to get those terms mixed up. Recommend making flashcards for them, just because they're those types of terms. So we'll talk more about that slide later. Don't worry too much about it. Let's go ahead then and talk about igneous rock composition. So far I have talked about how igneous rocks are defined based on whether they form above ground or below ground. Above ground, that extrusive igneous rock; below ground, intrusive igneous rock. But there are still so many different types of rocks that form above ground and form below ground. And we need to tell them apart. They do have different names. So not only are these rocks characterized by forming above ground or below ground, but they are also defined based on their chemical composition. What do I mean when I say chemical composition, or their composition in general? What I mean is that we have kind of this range, this spectrum exists. Uncover some samples here. It's going back. So we're going to go back to what we did last week, and we're going to go back to those minerals. Which minerals, you might ask? The ones I had you draw pictures of. That's why I had you draw pictures of them, because I wanted you to pay special attention to those ones, because those minerals are what define the 7 rock names that you guys are going to be examining in this chapter and have to talk about in your lab. Those minerals are the defining feature in terms of classifying them by composition. So felsic, the first slide there is dedicated to felsic rocks, what we call felsic. They are mostly composed of feldspars, like potassium feldspar specifically, and silica-rich minerals. So minerals that have a lot of silicon in them. Which minerals are those, you might ask? You didn't have me write down the chemical compositions of these minerals like you do your 102 class. You're welcome. But you're also not welcome, because then you don't know that. So the minerals that have a more felsic composition have more silicon in them and are lighter in color is going to be things like your muscovite, right? And your quartz. And we've got your feldspars here, especially this beautiful pink potassium feldspar. That's really important. The pink potassium feldspar, it's what gives things a lot of that pinkish, purplish kind of color. So again, mica, muscovite specifically, quartz, and your feldspars. And you can see that we've got those. We have some dark minerals in here. We have a little bit of biotite and hornblende, but just a little bit. They're not the defining, overwhelming majority of the minerals in here. It is mostly these minerals here. Let's see, what else do I want to say about these rocks? So because you have these minerals, it's mostly made up of these top row of minerals here. These rocks are going to be lighter in lighter in color, right? The extrusive igneous rock version of this is going to be a rock known as rhyolite. And the intrusive igneous rock of this type is known as granite. How many of you guys have heard of granite before? How many of you guys have granite countertops? Anybody? Someone says, yep. Nope, just laminate. Someone says they have marble. I have some marble too. I didn't choose them though. When we talk about marble, I'll tell you why I wouldn't personally choose marble. It's not very, it's capable of being eaten and dissolved away. So if you guys were sold granite countertops, I regret to inform you that it is not likely that they are granite. Salesmen don't know what they're talking about. When they tell you that they're selling you a granite countertop, what they mean is that it's a rock. And usually they're talking about either igneous or metamorphic rocks, and they just call all of them granite. Yeah. Because who wants to go through the trouble of saying, yeah, this one is a nice countertop? No, I mean, it is a nice countertop, but it's also a GNISS, made out of a rock that's called GI, or this, countertop here is a gorgeous peridotite countertop. Like, they just want to have one overall arcing sweeping name that means your countertop is a rock, and they picked the term granite. No, wrong. Granite is specifically referred to igneous rocks that are formed that have primarily this mineral composition. If your countertop doesn't have pink in it, or at least the subtlest hint of pink in it, it's not granite. It's just not. So here, this is granite, got a little subtle pink in it. Can you guys kind of see just the hints of peachy pink in there? We have a hand raise from Noah. What's up, Noah? Was it something I asked? And I am just now seeing the hand raise. And again, here's that fine-grained rhyolite. Very lovely, kind of pinkish, purplish, grayish. I have more rhyolites. And more granites. This is also a rhyolite. Here's the one I was holding before. They're pretty similar. Here's another rhyolite. It's kind of really pale gray with just hints of pinkish purplish. This one's actually also a rhyolite, I believe. Looks kind of more felsic to me because it's more that tan pinky color. Got one more rhyolite here I'll show you guys. This one's very peachy pink by comparison. This one's much more warm toned and cool toned. Whatever, doesn't matter. A couple more granites to show you guys. Yeah, let's show these ones. This is also a granite. It's kind of more in that pegmatite category. I'm cheating a little. But you can see that we've got largely these kind of pink feldspar crystals, quartz, some of that really glittery, beautiful muscovite in there. Here we have another granite as well. You can see some kind of hints of pink, some black crystals there, and a lot of quartz. But even though that there are black crystals there and that they're quite large, you can see that they are in the minority compared to the lighter colored minerals. So yeah, we've got kind of a range of different granite-like looking things. Granite is a bit of a range. I'm not sure what the granite looks like in your kits, but it should be kind of that same should look like one of these, or it might be like really small crystals that you can still see, but it might be kind of more like this guy. And it should have some of those pink or peachy pink tones to it. All right, enough about that. I've carried on for far too long about that. Let's move on here. Yeah, marble is a really commonly used architectural stone. Igneous rocks also get used. A lot of these rocks that we're going to be talking about get used as architectural rocks or countertops. Let's see. Let's go ahead and talk now about that middle rock section from that previous slide. This slide here. We talked about this row here. We got our rhyolite, we got our granite. Now let's talk about this middle row here, the intermediate row. We kind of call the first row the light, and then intermediate and dark. We also call them felsic, intermediate, and mafic. We'll talk about mafic next. Don't worry, guys. So the next kind of, there's a spectrum, there's some in-between stuff, but we're just going to talk about the major ones. The next one that we're going to be talking about, intermediate, is primarily defined by these minerals here, this composition. So the minerals that make up intermediate rocks, whether it was above or below ground that it formed, if the rock primarily consists of some quartz and some potassium feldspar or plagioclase, you're going to get definitely a lot of plagioclase. And you've got maybe the tiniest bit of biotite in there, and you've got a lot of hornblende, right? And you've got some pyroxene in there. Then you know you have an intermediate rock. And an intermediate rock that forms above ground is called andesite. Both of these are andesites right here. And an intermediate rock, one that has this mineral composition that forms below ground, we call it diorite. You might look at this and say, well, that looks an awful lot like granite. What's important to note here is that this rock is about equal parts dark minerals and equal parts light minerals, right? And you can see up here that I've got light minerals and dark minerals in here, but I've left the peachy pink stuff isn't in here anymore, the potassium feldspars. I think I said that they were, sorry, erase that memo. You really just have your plagioclase and your quartz, right? And then you have these, and it's not a lot of quartz, so just a little bit of quartz, right? And then you have these darker minerals, and it's about 50-50. Is that a JoJo reference? It is. Thank God someone got it. So my friend sent this to me. Her name's also Caitlin, and we were roommates, and we were both geologists. Caitlin, if you ever see this, I just want you to know I love you. But you already know that. She sent this to me, but she hasn't seen JoJo's Bizarre Adventures. So yeah, you might say that this looks a lot like granite, but it's not, it's diorite. This is a granite here. How can you tell the difference between these two diorites here and this granite here? You can tell the difference because there's only a few black spots in here. And this one is about 50, these two are about 50-50, right? So you thought it was granite, but it was diorite. Yes, exactly. Bigger, not necessarily that they're bigger dark spots, but that there's about 50-50 between the two. Granite has less spots. No, it doesn't have less spots, if you will. Those spots, again, are just individual grains of these dark minerals. And then there are also light spots. You can't see them very well because of my camera, but there are lighter spots, and those are these other minerals here, right? Going back to my favorite pegmatite, just because the crystals are so obnoxiously large. Freaking love it. So like this is one such spot, if you will. See this kind of square-ish thing right here? Maybe kind of sort of squint with me here. That's just one spot. That spot is a giant feldspar crystal. And it's like the size of my fingerprint. That's kind of awesome. You don't normally see them that large. That's why I keep gushing over this rock. And then this black spot right here is just one hornblende crystal. Remember, you drew a sketch of a hornblende crystal. So these darker areas here are hornblende crystals, right? Some of them are biotite in this sample as well. Some of those darker ones. So when I say the term spot, what I really mean is a chunk of a mineral. So looking at this again here, right? Wait, not this one. This one. So looking at this again here, we have about 50-50 minerals in there that are the darker ones, and about 50% of them are those lighter minerals, right? Is that making any sense? Oh, okay. Yes. Okay. I'm gotcha. All right. Yay. You guys are with me? This is great. Let's talk about the next column of rock back on this previous slide, which is this last one here. These are the mafic minerals. Mafic means magnesium and iron. Ferrous, iron. For those of you who are a little bit familiar with chemistry, magnesium and iron-rich minerals. So composed mostly of magnesium and iron-rich minerals. Which ones are those, you ask? You drew those ones too. So mostly dark, what I would call dark colored minerals. We have that hornblende. We have the pyroxene. We've introduced a new one. We've got olivine. And we have plagioclase here, plagioclase feldspar. If you'll notice, we have dropped all the minerals that I considered what I told you guys are the lighter colored minerals, such as quartz, right? Or muscovite, or the pinkish potassium feldspar. And now we're just kind of in blacks and greens, and plagioclase feldspar is a lighter colored mineral. It is, but it's not rich in silica. And that's what pushes it onto this end, even though it is lighter in color. And it's the one mineral that's lighter in color that you find in this mafic, in the mafic rocks. So I've got a few pictures down below. These two are the same. They just look a little bit different, right? Because rocks kind of, have a bit of variation in them. And then here we've got that aphanitic ground mass right here. And we've got the phaneritic rocks here. These ones formed underground. This one formed above ground. However, they all are made up of primarily these minerals, both, above ground and below ground ones, primarily this stuff. So when it forms below ground, we call it gabbro. And when it forms above ground, we call it basalt. So I don't have a lot of good samples of gabbro to show you, but I do have one that I grabbed from school. Oh no, what did I do with it? Story of my life, right? Just always losing things. Anybody else? Hashtag relatable. There it is. All right, so here I have a gabbro for you. You can see that there are some lighter crystals in it, but the overwhelming majority of it are like green and black crystals. So the lighter colored crystals are in the minority here. Let's see if I can get in just a little bit closer on this guy. So it's mostly dark for that reason. Let's see. I didn't actually show you guys my diorite. an andesite. I showed you an andesite earlier. This is andesite. This is a diorite here. Here's another diorite. Diorites. This one's not as weathered. So this one is not pink, I promise you. It's just weathered and it's dirty. It's a rock. Imagine that. So comparing the two, the intermediate, where we've got about 50-50 dark versus light, and this one, let's get you that fresher surface there, which is much darker in color. It's not 50-50. It's mostly dark. And then let's talk about the extrusive version of that mafic rock. It is basalt. So this is basalt. It's usually black or gray in color. Sometimes it's brown if it's been weathered and exposed to the elements and it's been through it, right? Yours, you do have a basalt in your, sorry, bumping that laptop. You guys do have a basalt in your kit. It should be number 9, right? This is what my basalt looked like in my kit. Yours might look like this too. There's a lot of holes in it. Those holes are formed by gas bubbles that are escaping the lava. And remember, that lava is cooling like super quickly. So the shape of the gas bubble as it popped is preserved as it cools and solidifies. So yours might be a little holy, but it's this fine-grained ground mass. This guy has some air bubbles in it too. They're just really small compared to this guy. Does your guys look more like this? Does your number 9 look more like this, or does it look more like this? Let me know. So one more time for you guys. These are the darker versions, the mafic rocks. More holes, yeah. We'll talk a lot more about those holes in the volcanoes chapter. All right. How are we doing on time? Doing okay? Let's go for just a little bit longer. That's pretty much the depth of what we're going to talk about with igneous rocks, is the denotation of above ground, below ground, intrusive versus extrusive, right? And then also defining them based on composition. Oh no, there was a slide that I forgot to transfer. We're going to talk about one more type. So let's talk. There's one type of rock that's not on here. So going back to this slide here where you've got the light, you have the felsic, intermediate, and mafic. There is actually one more category, and you guys can see this in your book. Go ahead and turn to page 52 if you have your book out. Let me see if I can do this without spilling stuff everywhere. So they've got their light here. This is the felsic category. Here they have the intermediate category. Here they have the mafic category. And then on the last one here, it says ultramafic. And they've got photos of these rocks here for you, right? Where they have, the granite and rhyolite. They've got the diorite and the andesite. They've got the gabbro and the basalt. And then they have a photograph of peridotite there. And then they don't even have a photograph of a rock called komatiite there. Komatiite is so rare that I can't even get my hands on a sample. I tried because one of the geology instructors approached me as a lab technician and was like, hey, can we get one of these samples? And I was like, I'll try. Let me, look up online, see what they go for, if I can get one from maybe Award Science or something like that. No one even sells these because they're so rare. You just don't, that stuff just doesn't reach the surface of the earth. You can look up more about that if you want to know more on that. However, we do find a lot of ultramafic rocks that solidified whilst they were underground. So I have a sample here. A student, a grad student at Central Washington University gave me this one. It looks a lot like gabbro. This particular one does. It almost is more of a gabbro, this one. Remember, there's kind of like a range or a spectrum, and this one's kind of a little bit in between, right? And here we have basalt on the exterior of this. My volcanology professor called these like M&Ms, where you've got that crunchy shell on the outside and then you got other stuff on the inside. So let's take a look at a very true peridotite. Where'd she go? Here she is. So this peridotites, these ultramafic rocks, are almost completely formed of olivine and pyroxene. There's no hornblende, there's none of the other stuff. It's almost completely olivine and pyroxenes. You might have some plagioclase in there, but not very much. This is one such rock here. This one happens to be very largely pyroxene, and so we call it a pyroxenite. Specifically, we call it a pyroxenite. But it is still, by my opinion, in the introductory geology opinion, we're still going to call this a peridotite ultramafic rock. You can see that it's mostly green, ranges also to dark green, kind of the backside there. Yeah, it looks the same. Whatever. We'll move on. So that's that. Maybe I will throw in, you can Google like komatiite. They look really weird. It looks like basalt, but with weird textures on the surface. Yeah. So if you're curious to know more about that, check that out online. All right. How am I doing on time? In the last, 10, 15, 20 minutes, let's talk a little bit about weathering. It's really hard to whittle this lecture down. Normally, we spend 3 weeks on this 1 week for this class, and I am used to going into a lot more depth. It's hard for me to reel it back in, guys. Doing my best. So let's go ahead and switch gears now and start talking about mechanical weathering. Again, review for igneous. Nah, you don't need review. I'm quite long-winded. Let's just keep going. All right. So let's talk about weathering. There are two types of weathering, two main umbrella categories. We have mechanical weathering, right? Mechanical weathering is sometimes also called physical weathering. And we also have chemical weathering. So there's that mechanical, physical weathering, and then you have weathering that takes place on a chemistry level. So mechanical weathering, just weathering in general, weathering is defined as the process of breaking down rocks into smaller rocks. It really is that simple. So there are some common types of weathering, and we're going to talk about these particular ones. There's like wind abrasion, frost wedging, salt wedging, sheeting is what your book calls it. I am used to the term exfoliation. Not the kind of exfoliation for your face, but you'll find out. And also like biological activity, as well as like other kind of chemical weathering that we'll talk more about. So let's first talk about the types of weatherings that I just mentioned, which fall into the mechanical or physical category. So these don't take place on like a chemical weather. This is literally the child sitting there with a hammer, smashing up objects into smaller bits and pieces. So here I have a photograph of wind abrasion that's been taking place. What happens is, just as it sounds, you have wind coming along, and that wind is carrying really small particles. And when those particles collide with another rock, it slowly kind of chips off little bits and pieces of that rock and produces more fine-grained particles, which can then be carried further by the wind to abrade yet another rock and continue to break rocks down into smaller bits and pieces. These two photographs are some excellent wind abrasion that's gone on. This one's a ventifact. In case you're curious, that's a cool word, ventifact. This is called a hoodoo, also sometimes called a yarding, I don't know. So that's wind abrasion. If any of you guys are familiar with sandblasting, it's the same thing. And it's really that simple. It's just that easy. So let's talk about another type of mechanical weathering. We're going to talk about frost wedging, right? Has anyone made the mistake of putting a water bottle that was full into the freezer? I know we did this on our geology field course with Nick Zettner. Or I don't remember who did it, actually. But there was a student or two who forgot to leave a little bit of space in their water bottle for the water to expand while it froze. Let's see, international experiment, but yeah, cracked a jar with water expansion, indeed. Right? So what happens, particularly with frost wedging, frost is water, and water has this unique thing about it that when it freezes, it gets bigger and it takes up more space than when it's in a liquid state. So as stuff freezes, as water freezes and expands, it pushes apart. If it's found its way into a small crack as liquid and then takes up that whole space and then freezes, it's going to expand and it's going to push apart whatever's bounding it, and it's going to try and wedge it apart, hence the term frost wedging. It's also why we have potholes. We don't actually have too bad of a problem with potholes out here in the Pacific Northwest, whereas if you go into like the Midwest where it snows a lot and it freezes a lot more in the winters, they have really bad problems with potholes and they have to pave sometimes like every year. What happens is that the water seeps down into that asphalt, completely takes up all the space there, freezes, and then expands and wedges apart material. So that's yet another way that we can break rocks down into smaller rocks. Let's talk about salt wedging. It's pretty much the same thing. So let's see, Noah says, yardings are common in parts of the Sahara. Yes. And you can also see a lot of them in Utah too. Yeah, so Utah, you can see a bunch of them here but they're probably not as common as in the Sahara. I have a feeling that there might be more there. So salt wedging, I've got a photograph here. Basically the same thing, except usually you have like a salty sea spray, or perhaps you have groundwater. There's actually water underground. And if it's like salty, or you've got like sea spray, and it evaporates, it creates like crevices and pore spaces, right? Salt crystals will also, like, if it solidifies and the salt crystals like can grow larger and larger and larger, it will also wedge apart the surrounding material, helping to break it into smaller pieces, right? let's go ahead and keep plugging along and move on to the next slide here. Let's talk about exfoliation next, also known as sheeting. I don't know that I ever heard it called sheeting until I picked up this particular textbook. So sheeting occurs, right? This is a photograph of sheeting right here, exfoliating rock. When you have these like concentric slabs, typically it occurs on intrusive igneous rocks, so granites and diorites and gabbros. This is typically observed on those kinds of rocks. And they break loose and they really do come apart in like sheets. If you're hiking around in the Cascades at all this summer, or on a different summer when it's safe to go outside again, keep your eyes peeled if you come across like a large igneous rock, and you'll see sometimes this sheeting occurring. I've seen it a lot on hikes in here in the Cascade Mountains on Snoqualmie or Stevens Pass. So you have removal of the overlying rock, right? Because you took one shell off, like the top shell. And then that reduces the pressure from the rock that's below it in this giant outcrop. And then it expands basically because it's like, oh, wow, I feel like a tremendous weight has been lifted off of my shoulders. You know, I feel like I can breathe again. And it expands and then sheets off again. And then the rock below it also like expands, right? And there might still be some, I think it actually is more that you have rock above, but it's just less so. And it breathes and it sheets off the rock above it. So they expand and separate. So let's talk about mechanical weathering in terms of biological activity. So if you have plants that are growing, sometimes you'll see these roots growing down into the cracks of rocks. And trees and roots and things, they get bigger. And as those roots get bigger too, they push the rock that they might be growing into apart. And that also breaks the rock up into, yet again, smaller bits. Sometimes you also have burrowing animals, right? And those burrowing animals will expose rock. Like, say you have rock that's maybe underneath some like dirt and stuff. These burrowing animals might end up uncovering some of that stuff and exposing it to the elements where a different type of weathering can take place. The next type of weathering, we've got one slide left, ladies and gents, and it's 4:30. Chemical weathering is the last umbrella. We've talked about various types of physical weathering. So now let's talk about some chemical weathering. All right, so chemical weathering alters the internal structure of the minerals themselves. You may have heard me say this sample is very weathered, right? What that is, chemical weathering, think of like rust, right? You've gone in and you've chemically altered, say like a tin can by corroding it away. And that's what's happened to, like, say this example here of hornblende. One side of it, you've got some nice pristine crystals, right? And the other side is just like all crummy and it looks kind of rusted. Rust is not the only kind of weathering. This granite is also kind of weathered. It's not super pretty anymore like it used to be when it first formed. You can see examples of weathering. This is a fresh surface. The surface here has not been weathered. Whereas if I flip it over to the back, this surface is not as shiny and pretty, and it has been weathered compared to this surface. See the difference there? So the internal structure of those minerals has been altered, right? Elements have been removed or added. The original rock is also oftentimes transformed into a different material that's more stable. So it's not too common. I have one here. Not really. It's not too common in granites that are really weathered. Oops, sorry. To see green crystals. And that's a new mineral that's formed as a result of weathering, as a result of that internal material changing into something that is a bit more stable given the elements that it's being exposed to. Water is the most important agent of chemical weathering, right? It's the biggest agent that causes that chemical weathering, or brings in dissolved like oxygen, brings in carbon dioxide, right? So if it brings in oxygen, we get oxidation. If it brings in carbon dioxide, that's that carbonic acid, and it eats away at stuff, right? Another way that chemical weathering takes place is from the living and decaying plants and animals, right? So if a plant dies and falls onto a rock, that withering plant actually produces acids as that organic material decays. Same thing if an animal passes away. Animals that pass away will produce these acids as their body decays. And that can also eat away at the rocks. So I have some photographs here that are examples of this chemical weathering kind of processes. This one in particular here is kind of neat. This looks like either a basalt or a gabbro. And it has been exposed to the elements. It's been through it, lots of wind, rain, sleet, and snow. And as a result, we've developed a rind on this rock of that weathered surface. Beautiful example there. You don't normally see it so clear cut like that. And we call it a weathering rind. Here, this is a cave, as you can see, and it used to be solid rock. However, acid in the rainwater, in the groundwater, has eaten away at this particular stone that this is made out of. This particular type of stone is made out of limestone. You can get, this happens to marble too. They're cousins. And it's eaten away at that stone. The acid has, and it's created these large caverns that we call caves. So that's it for today. We talked about igneous rocks, classifying them as either forming above ground or below ground, and also classifying them based on their mineralogical composition. And we also talked about weathering and how you break larger rocks down into smaller rocks. And weathering can happen to any type of rock, whether it's igneous, metamorphic, or sedimentary. But it's important for when we form a new sedimentary rock, we need to be able to break down other rocks into smaller bits and pieces in order to make a sedimentary rock. And that's where we will pick up on Wednesdays. We're going to talk about those sedimentary rocks. We're also going to have, by the way, for the 6 of you who have stuck with us, we're going to talk about on Wednesday our exam. We're going to have an exam next week. I'm still working out the details because I haven't done this in an online class before. So I'm not sure if I want to have you take that exam partially during when we would have had class time and then start lecture up after that. I do want to have you all take the exam though at about the same time, or at the same time, and it is going to be a timed exam. Again, you'll want to know your material because you won't be able to finish it in time if you don't. You can use whatever resource you have available to you because you will anyways, and it's not fair to those who would actually listen to me and not use resources that I ask them not to use. compared to people who are like, I really need this grade. I'm just going to use whatever means necessary. Don't worry, I get it. But as a result, that means that the test is still going to be constructed in such a way that if you're looking up every single question, you're not going to finish in time, and you'll still get probably a failing grade, honestly. If you're looking everything up, you just won't have enough time to complete enough of the test to get a passing grade. So even though it's open to everything, trust me, don't fall into that false sense of security of, well, I can just look it up online while I'm taking the test. Don't do that. You'll shoot yourself in the foot. If you're okay with failing, then by all means, go right ahead. I don't recommend it though. I like getting my money's worth when I pay for a class. So yeah, more details then to come. Let's see. I think that's all that I wanted to talk about. Keep your rock kits on hand for Wednesday, and keep your eyes peeled. On Wednesday, the slides should be updated, and I will have more slides for next Wednesday's lecture up. If you guys have a preference, I think I might do kind of a poll, perhaps in an announcement on Canvas, asking you guys, I don't know, what you guys would prefer for lecture and test next Monday. Would you prefer to do lecture maybe at a different time, since you can come back and rewatch these, and have the test taking during the time when we would normally have lecture, because everyone's set that time apart already to dedicate to this class, hopefully. And everyone can take it at that time. Everyone's going to be available at that time. So the test can be at that time. And maybe we just do lecture at a slightly different hour. And those of you who are available can watch it live. And those of you who aren't can maybe watch it later. So yeah, I think I'll post an announcement, kind of surveying and trying to get a feel for what's going to work best for people. I have a feeling that you probably won't want to do like lecture right next to the test. Yeah, I know how that goes. I feel for you guys. Okay, well, with that, I don't think there's anything else that we need to talk about. So have a happy Monday and happy Tuesday, and we will see you guys on Wednesday. If anyone would like to do a Google Hangouts session after this, just to ask questions, either for clarification about the lab or questions about what we covered today, go ahead and let me know. I will use your student email, so you can just say, I want to be a part of the Google Hangouts. And what I will do is I will send an invite to your student email. And you'll want to be logged in. Your Google account that you'll want to be logged into is your student account, not a personal Gmail account. And then you can get that invite. So let me know. All right, I'll probably wait just one more minute, since I know there's a delay in the chat. And if I don't see anybody in the next minute kind of comment in the chat that they want to do a Google Hangout session, then I will probably move on and end the live stream and begin working on grading and getting a bunch of other things, productive things done. Bye, Genesis. All right. Let's see. So I don't see that anyone's requesting to have a meeting. So with that, then I will go ahead and hop off of this live stream and start working on grading your guys' assignments. All right. Cheers.